Hello good day viewers. In today's tutorial we are going to see how to determine the ID and V node of this parallel circuit. So this is another question that is different from the 7th question we did in the last videos. So how can we determine this? You have to take a look to these diodes, two diodes, and first check are they on or off. The silicon diode, it is what? It is 0.7. The gallium arsenide, which is 1.2. So you have to take a look to this circuit. First diode move here and the first diode move here, and therefore they go to this point. So it is possible that this diode will pass here and therefore this diode must go here. Is it possible the two diodes at the same time will move to what? Will move to this V out and therefore will go to what? Will go to this resistance. Is it possible? So this will not be possible. This must be what? This must be off, because this 1.2 it is more higher than what? Than this 0.7, and this 0.7 it is more less than this 1.2. So therefore there is no possibility of this of this gallium arsenide to be on. So therefore this gallium arsenide diode, it is what? It is off. You are just going to concentrate on this diode which is on. After then you're going to apply the KVL, move here, and move off to here to find your currents. And therefore if you are going to find voltage as usual, move to what? Move to here. So how can I find this? So let me use the drop, negative to positive, which is what? Which is dropping, and positive to negative, which is what? Which is rising. So I have to say this is when this is dropped, the rest will be what? Will be rising. So therefore plus the 0.7 the diode, and therefore plus what? Plus 4.7 what? ID should now be equals to 0. Minus this plus what? Plus our end with minus what? 11.3 plus 4.7 what? 7 ID should now be equals to 0. So I have to have 4.7 what? ID. This should now be equals to, when the negative 11.3 cause the equal sign, it will now be what? 11.3. So if I divide both sides by what? 4.7 by 4.7, 4.7 will cancel 4.7. So therefore the diode current should now be equals to 11 divided by the value of what? Divided by the value of 4.7. What should I get? So let me check. 11.3 divided by 4.7. So this should now be what? The current should now be 2.4 watts. Because of this kilo, it is what? Milliamps. You have to understand, if you are using the kilo, it will end up with 0.000 something, as I explained in one of the last example. So therefore if you will exclude what? The kilo at the end, you come and use the kilo. So therefore the kilo, you now inside what? Milli. It's the same thing as what? Milliamps. So how can I determine this voltage? The V out minus what? Minus 4.7 watt. ID should now be equals to 0. So the V naught minus what? 4.7 multiplied by 2.4, it is equals to 0. So therefore the V naught what? Minus this multiplied by what? Multiplied by negative, or let me refresh it, 4.7 okay, sorry, I have negative 4.7 multiplied by what? 2.4. So this should now be equals to minus 11.28, which is equals to 0. So therefore the V naught should now be 11.28 what? 11.28 volts. So this is all I have for you for this. Don't forget to subscribe to this YouTube channel. So let's meet in the next 9th video.